Doug Royer, Solutions Engineer with ThousandEyes. Been with the company almost 2 years now. So today I'm going to walk through 3 quick examples. The first we'll kind of use to stage, if you haven't seen ThousandEyes before, what the environment looks like, how we interact with some of the things that Mohit mentioned, the deep path analysis, the X-layer technology, as well as interactive sharing. So today I'm actually accessing these links as share links. And so the first event that we'll actually go through is HSBC, a DDoS event. And so a lot of the times these are shown publicly. It's disasters, frankly, that things aren't going right with the mitigation providers or they don't have any. This is actually a happy story since it's early in the morning. It's a provider who's actually doing their job well and picked up the traffic very quickly and mitigated the event. So we'll start there. We heard a report of this event happening, and we actually had some tests set up. So we'll start at the beginning of the left-hand side of the timeline. We keep, by default, 30 days worth of data. You can interact with it, zoom in on just a test cycle. And so across the top, we have the timeline. On the left-hand side, we have the errors by type. And so the sales rep that I work with likes to think of this as the cheat sheet. So if you see things that are at the top, DNS or TCP Connect problems, it's probably the network. If it's not, go down to the bottom. It's more likely a server problem, wake up the application team. And that's how he thinks about kind of all of these events. And if Nils can look at these events and piece them apart, or his 8-year-old daughter really can, like I'm convinced that anybody else in the world can actually just look at this, simply say, is it the network or not? And so, but we do go deeper than that. So we have the world map. The actual locations that are airing out are in red, and we give error details specifically about what's happening. There's IP address, there's a lot of information. All this is also accessible via the API. So some of our customers, by default, just have this up on their knock screen. Others scrape the data, wait for an alert, and then fundamentally just start to log in and use this as a device or a tool to troubleshoot it. So we have
quick question there.
Yeah.
You said you keep 30 days worth of the performance test data?
Yeah, we do.
Is that rolled up in any way, or do you have 30 days of full resolution of all your tests?
30 days full resolution, then it rolls off after day 31. We've also have the ability to save off snapshots. So if you have a particularly interesting event that you want to save for a quarter, or a learning experience for somebody, you can save that off. We separate it and keep it static. So within this view, we have availability, response time, for example, connect wait time. Also throughput. So one of the use cases here is that sometimes people have large driver downloads. They want to see how well their acceleration services are working or not. So throughput's calculated from there. But just to jump back to this event, we see 4 locations. 3 in North America are alerting, and 1 in Asia. So we definitely know that something's going on. Looking at the end-to-end metrics view, this gives us loss latency jitter as well as outbound bandwidth from the enterprise agents. And so we can see here, 90% down to 58% loss from all the locations. So we definitely know that even though there wasn't a dip in availability in these locations, there definitely was high loss, which would affect the users or anybody going out to that website. So now we use the jump to. So this is when Mohit mentioned the X-layer technology. It's the ability to move from test to test to test in terms of looking at loss, looking at jitter, looking at the path visualization, all keeping at the same time slice and being able to interact with it back and forward. So here we have probably the most unique piece of technology in terms of the core platform that we initially rolled out, the path visualization. On the left-hand side are the agents. So these could be your branch offices, they could be your data centers where you've turned on our enterprise agents, or we also have the cloud agents. And so that's our own servers, and you rent a fraction of those, saying I want to go to this location this often from or out to this destination. And so if we pick Tokyo, for example, on the top left-hand side, we have 8 hops that are being obscured here from Tokyo to in this case, Alternet looks like it's in Chicago, inside of Verizon, and we go 2 hops forward, and we actually see the node that's actually terminating to the route, 70% of the traffic. We have the IP address, the prefix, the network, the location, as well as the average response time off of that link. We also have a quick selection here, so if you just want to see a list of what's going on, and more typically if there's 50, 60 of these, you just want to kind of get a list quickly, see what's going on. In this case, AT&T services and Verizon are actually the providers. So with this in place now, we can actually take a look and move forward and see that from a path visualization perspective, the loss is gone. We move forward about an hour, and the network's completely changed. But in order to exactly see what happened and how they actually took care of this DDoS event, we'll take a look at the BGP route visualization and using that same jump to technique. So the BGP route visualization goes through and no problem at all. So the BGP route visualization gives us a slightly different interface. So the destination or the origin is in blue, and the providers are in gray. And so as we roll out here, we see that VeriSign infrastructure operations is actually one of the primary. We have city locations also spinning off of these providers, and so those are the monitor locations that are feeding us the BGP routes. And ultimately, the origin in this case is VeriSign registry services. So if we jump back to the beginning where we are actually seeing the loss, we can see the shift occurring. And in this case, we have the inactive origin from HSBC along with their provider, Verizon, and the dotted line indicates the route's been withdrawn. So now we have the change, and again, this is looking at a 15-minute window, so you can, if, for example, routes were flapping, you would see a lot more activity in this. This is pretty clean, and you can see that we can also change the view here. So this is path changes, look at it from a reachability perspective or even from an update perspective. But again, to jump back into the initial screen, or actually into the path visualization, as the traffic gets absorbed by VeriSign, we can see a couple different locations here are actually letting us know that the VeriSign DDoS protection services is taken over. As we move forward then, there's actually a slight blip here, and we can actually see when about 24 hours later they've moved back to their own service, they've turned off the DDoS monitoring, and it's just a great example of actually the DDoS services working well coordinated with a bank to absorb that traffic. And I think one of the primary use cases for us at ThousandEyes is just taking a look and making sure that those handoffs work properly, cleanly, and whether it's DNS or BGP, that we can help you make sure that that's done right, and they're not always done right. So, any questions about this?
What does the path visualization look like in a GSLB scenario?
GSLB, a lot of it aggregates out in terms of, I've got a CDN example that I'll show you, and it's actually kind of the opposite of that. So GSLB will actually have a whole bunch of locations. If we go to this one, for example, rather than here and here, you might see 20 or so, and then it aggregates down to 1 on the right-hand side.
Do the probes just remember all the places that the website lived and keep trying them all, or?
So in terms of that scenario,
sorry, just want to clarify the question. Are you referring to a DNS-based?
Yeah, DNS.
Okay, so
GSLB.
Each agent will query for that domain and get an IP address. So if you're balancing traffic from Tokyo to the Hong Kong data center, it's only going to go to the Hong Kong data center. And what you'll see in the map here, on the right-hand side, you'll see different IP addresses on the
There's just
right.
several trees. That
Yeah, so there'll be several disconnected trees. And one of the things that's really interesting as a feature here is if Doug, if you can go back to the pathways, there is a small checkbox which says group by continent. And what will happen when you click on the group by continent on the top there is, next to that, is you now have the left-hand side collapsing into one continent. So if you have, if you want all of Asia to go to Hong Kong and it's not, you would see several connections going over to another tree. And so visually you can instantly correlate if GSLB is actually working correctly or not. It's really instant visualization on that.
In the case of a geographic or some sort of a sticky GSLB, I can see how it would be many trees and look pretty clean.
Yep.
If I just round robin GSLB.
Yeah, so if you round robin, you'll see each cycle potentially changing.
I see.
Maybe if you want to see that real quick, we could cover the Capasa example if you have that. That has 2 IPs, and
absolutely,
we can cover that.
I can actually, you want me to grab it now?
No, that's fine. Okay,
I can show that at the end, but we do have an example, and I've actually seen that from device manufacturers where they're trying to troubleshoot a round robin, and Russia is complaining about slowness as well as Europe, and suddenly you're going to Texas data center and then 1 microsecond Atlanta, and using ThousandEyes you're able to actually see this location in Dallas is actually having a problem. Even though it might be 10 minutes apart till we actually hit those same locations again, we actually get down to exactly what's happening. So, any other questions?
What about IP anycasts? So if you're kind of originating the same prefix for a service, have you got the ability to kind of maintain statistics for the same prefix, even though from different kind of, I don't know, origination locations? What DNS do sometimes, don't they, in some CDNs?
In terms of are you looking at from a DNS perspective, or just in terms
from
of
a purely IP perspective?
We could pick an endpoint within that block and measure out to that.
Can you clarify the question? Are you saying how it's visualized, or what's the question?
Yeah, how it's visualized. So if you've got the same prefix originating from several different ASs kind of thing.
So in that sense, when you look at this graph here, if you notice you can keep this one. So the white nodes here, what you'll notice is in an anycast situation, they will all be different airport codes, because your next hop is one hop away, but it's in like complete different geographic locations. And we see this, we might be able to pull one out in the end if we have some time. You can see this for DNS blocks and so on where it's anycasted. It's almost too easy to spot when you show the graph viz, because instead of the 2 or 3 upstreams, you'll find a stream of next hops which are all a few milliseconds away, as opposed to being the 100 milliseconds away. And just we even thought about at some point automatically detecting these anycast situations just based on latency heuristics. But
we also see it in that.
One of the customers is VeriSign, who uses it a lot for anycast troubleshooting, and this is primarily because it's really hard to troubleshoot anycast situations. And with the pathways, you know that there's a DNS problem, but on the pathways you see which instance it's going to. Even though the termination is the same, the next hop will give you an idea of what anycast instance it's going to.
Okay.
Good. For web instances also, we have the headers involved in there, so it's also another nice little clue in terms of what's going on or when things are misrouted. So the next example we'll go through is actually a misorigination event. And so I'm going to skip over the first couple views that we traditionally show. There's a dip in availability. It's slight. You see at the top right-hand side, 6% loss. And we'll actually jump in. So this is what we see in terms of a CDN-like behavior. Agents on the left-hand side, the numerous IPs on the right-hand side. In this case, you can see that we're inside of Akamai and various locations around the world. This one happens to be inside of Massachusetts. So typical from a response time perspective, 1 to 10 milliseconds is another clue. But path visualization, this is a dead giveaway. Within this, we actually, when we take a look at the actual test itself, what we're seeing here is a whole bunch of different locations, and Raleigh, North Carolina is the sole cloud agent that's actually having a problem. So we're inside of Ashburn, inside of PCCW, and pretty innocent looking, not a big deal, but still something we'd want to keep an eye out on. To take a look at it a little bit further though, in that case our customer actually took a look at the BGP view itself. And so again, we have Origin AS in blue, but in this case we have 2 of them, which was a little bit off. We have Akamai 166.25, their ASN, and a whole bunch of locations in green off of that. That looks great. But separately then also, this was back in April if you recall, Indostat normally has about 300 prefixes. They, I guess, announced about 417,000. And so if we look at it from their peering relationships, PCCW is actually one of that was involved in that change, and that was actually, if we go back to the path visualization now, taking a look at it, one little blip on the path visualization was actually the hijacking. So we saw a couple different examples of this. This is probably the cleanest and the most simplistic, but again, it's a pretty major event. We have alerts that can be configured to, for example, on the BGP side, even for CDN providers, Origin is not in, and fire off an alert, wake people up, and more often than not, we're actually finding that our customers know more about the CDN networks than they do by themselves, or they call up and say, how do you know that? And so that's pretty exciting for us. So, any questions here? All right, well, the last event I'm going to show here happened just a few days ago on the 4th. And this event itself was a little bit unusual. We have a standing monthly or weekly call rather on Monday where a bunch of the solution engineers and I get together and look at various events, talk through whether they're good demo examples or things that we can't quite figure out. And this is one of them that Pete Anderson, our SE out of the Southeast, came up with. And so we were looking at it, again, a whole bunch of different errors, some connect, some SSL, some receive. And we jump into the path visualization, and end-to-end metrics gives us a slight clue in terms of 100% loss from 2 locations, complete disconnect from others, and latency in others. And so, again, we don't quite know what's going on. Taking a look at it from the perspective, the provider in this case is CC Services. So AS10511, that's the destination rather, and we have access to go as the provider. If we go forward in the timeline, we actually get a slight clue, and we can actually expand out these hops. We're inside a Quest, so pretty simple, benign example. Looks like they changed ISP, had some sort of failover. But in terms of, again, from the BGP Route Visualization, we're taking a look and move it out a little bit. This is what caught Pete's eye. So 15011 is out there. It doesn't have any monitors, and that's an unusual data configuration. So what we actually had to do is reach out to our customer success team. They have access to the raw data. And what we found out that it was a AS prefix or AS prepending that had gone wrong. And so in this case, 10511 was the intended, but 15011 was actually typed in there in terms of one of the 4 or so locations. And so we'll call out the good folks at Jaguar Communications for not hijacking that traffic. It was reverted back 3 days later, no harm done. But again, it's a great example of, hey, we're just going to switch ISPs and no big deal. But when it's not done properly, then it doesn't. It gets kind of scary.
It's just 1 digit off here and there. It doesn't make that big a difference.
Yeah, I'm slightly dyslexic, so you know it happens. But any questions about this?
Wow. One question on BGP. Can it do RPKI validation of prefixes?
Ricardo can take that one.
The answer is no, we don't support that capability right now. That's something eventually we can implement in the future. We do not have a lot of ISP customers at this point, so we don't have a lot of requests around that. But
you were the first request for that one so far, if I remember.
Yeah.
But we'll log that.
Now, where do you get the BGP feed data from?
Today, we have 2 different ways we can get it. We do aggregate some of it from existing feeds, RIPE, REPUs, and so on. We also have a private peering, which we actually launched last week, I believe, and that allows on an enterprise itself can peer with ThousandEyes, and I don't know if we're going to go into that later in the talk, but
you can talk about it.
what it allows a customer to provide is from their own route reflectors, their own perspective and inside-out view of the world, and they would show up as one of the monitors here as well. So,
you said you're going to talk a bit more about that later on?
We can answer questions if you have it about it here.
If you are, it's cool, because it's something I'm quite interested in, is enterprises and how they can, I guess, it's cool if you've got like the public internet view, but you sort of want to hook up your own enterprise network view of it as well. And so, we'll pick it up later on if you want.
Yeah, and there's a couple things just to add to this as well, that when you see the path visualization here, you're seeing the outside in view. But because you can actually put the enterprise agents on the data center side, you can trace back, so you can get both directions, and it's a much more complete picture. But we haven't covered that in the specific examples here. But our enterprise customers are using it in both directions, which makes it right.
Cool.
Any other questions?
What's the general response when the customers are going to these SaaS providers and saying, "Hey, we have this," and they show it to them? Do they buy it? What's been the response to the customers?
Oftentimes it's relief from the SaaS provider's perspective, because if they're getting something that has this data, they know it's actually something inside of their environment, not a misconfigured Wi-Fi. We've also had situations where we've kind of been working with both the SaaS provider as well as the enterprise customer. And that's actually pretty fun because you can see it's not always one-to-one. It's, hey, this is your gateway ISP that's completely overloaded. Don't blame XYZ SaaS provider. But actually this other example 10 days later in the trial is inside of their environment. So you kind of get the executives to see, it's not black or white, it's both parties are to blame, and we can actually help you figure out where that outage occurs and why, if there are people using applications who are sitting idle. So especially
No, this is a good point. The other use case is planning, right? So if you're going to deploy Link in your environment, you have lots of sites, and you want to make sure that your latencies to Link are within a specific range, right? You can visualize with ThousandEyes from the enterprise what are the paths, where you might potentially be routing things wrongly, where there might be bandwidth issues, and this is some of the stuff that Ricardo will cover as well. The idea is to capture as much about the network as possible without really instrumenting the things that are on the way. And so from a standpoint of planning, there are some really interesting use cases in addition to troubleshooting, which we focused on in the demo here.
Just a thought, thinking about this in terms of enterprise. You want to make sure your apps are up or stable performing, and if not, you can use this to sort of help the carrier out or help the SaaS provider out. But if I was an end user, I would just say, you tell me what changed if it's regarding the public internet. So is more of your target customer, is it really the SaaS provider? That way you can sort of offload from going to every enterprise to try to actually sell the service and solution.
So we have actually gotten quite a few introductions into large enterprises because the SaaS companies are troubleshooting a problem. And we're in a situation where these guys know that it's not on their end, but they have to field these calls. So they would say, hey, ThousandEyes, can you just help them out? And they'll figure out what's going on.
So it could be almost like an OEM through a SaaS company.
Yeah, and so we're actually we're going to launch a partnership with one of the top SaaS companies in the next 4 weeks. And so you'll hear about it at a large event. I can't believe how anonymous I have to get about some of these things. Somebody will talk about it at some large event, and
you have smaller deployments that are also having that like it as well.
Yeah. Smaller deployments. So from a pricing standpoint, right? It's at the point where an enterprise agent costs you $99 a month per location. So if you have 3 sites, you can get started at less than $300 a month for all your applications that you rely on. That's a really great starting point. And then it depends on how far you want to go, because there are modules, there are public testing, and so we're not really, even though a lot of our customers are large ones, we're not by any means ruling out the smaller ones. We do have a lot of small customers as well, who are local providers or local companies, enterprises with 5 or 6 offices, and we're finding that they actually have very interesting problems as well. It's not just the complex networks. And they wake up at night as well. So
just one other one just made me think about it. So the public agents and whatever, and I can, you've got your public agents deployed, and I can say I want a test run from Tokyo and LA and whatever. How many locations are you up to now for that?
We've got about 80 right now, and we're putting more up. The focus on the growth side for the locations is areas where we see lots of problems. So Asia in particular, is really problematic. So we're growing within China, within parts of Asia, Indonesia, Malaysia, these regions which are problematic.
One of the reasons I ask is because I'm from New Zealand, and
we do have an agent.
We get kind of ignored by most people, So it's
we do actually have an agent in New Zealand, and
cool.
I wanted to go and personally install it, but that didn't happen.
So a company that I worked with that ended up deploying ThousandEyes after I showed it to them following NFT6. What they actually did was they took some of the enterprise agents and are running them at various cloud providers where they can choose where they're going to run, right? So they're running one in, AWS West and one in, one or whatever.
They're doing it as an enterprise agent, but
they're using the enterprise agent, but they're running it at various cloud providers to give them some perspective.
Gotcha.
And that gave them a very cost-effective way to get a view of their application performance of the API host from.
It's not much to spin up an AWS VM.
Yeah, correct. So
the cost is low, and then they're running one internally as well, so they've got both the view of hey, is this problem happening within the application because even my local agent that's running in the data center is reporting the same, or is the local agent reporting good performance and then the one that's over here? So they don't get the complete view of 80 some test points, but they get.
Enough for what
it's an easy way to get things, spun up from a couple of locations and get a view.
Yeah, and we actually have a few customers who build their own external infrastructure similar manner. They just deploy agents in different locations and get it. And by the way, .nz uses us for what it's worth. So if we do have some presence in New Zealand, it's not as much as we'd like to in the future, but sure.
So for Amazon, do you support AMI images, or do you support multiple providers, or can you just install it on
It's a Linux
on
package, so just quick
Yes.
install. Yeah.
Spin up CentOS and
Yeah, I think there's some Puppet recipes and stuff, Puppet manifests
we do
and
have
things
that,
and
yeah.
whatever. It's all.
We do have that for the mass installs and the mass configs and so on. And the agent installation and setup is really easy. It's meant to be literally a drag and drop, kind of just click download and turn it on, and it just works out of the box. That's really the setup. The other interesting thing we can do, guys, is if you have specific domains that you guys own or are responsible for, you can send them to Lindsay, and we'll try to set up some tests, and maybe towards the end we can look at some real data. This is always a fun exercise to actually look at real stuff, and you might be amazed at what you'll find in your own environment in this session. So feel free to send notes to Lindsay, and in the next 15-20 minutes we'll set up some tests. In the end we'll cover some assets that might be interesting for you guys.